Okay, so this is a session about personalization and recommendations using Drupal and some of the Drupal modules and external software available for that at the moment for Drupal 6 and 7. My name is Klokie. This is Daniel Harris. We're working with Kendra Initiative in the UK, although I'm based in Stockholm, and Daniel's based in Devon in the south of England. So there are a number of buzzwords associated with making recommendations online. It's a pretty popular, quickly growing industry at the moment, which is why it's so exciting that there are some possibilities for leveraging Drupal and available technologies to do this using completely open source systems, depending on what your resources are. So Daniel can give you an overview of what we're doing.
Okay, hello. I've got to say a little bit about Kendra because that's where we're getting the funding from to do this. And actually, we've been funded from the EU. You might be interested to know we've been funded twice with several hundred thousand euros. So if you're interested about how to do that, speak to me. I've been on two European projects. One is called Peer-to-Peer Next, where we've been looking at metadata interoperability, and Saracen, which is, well, you can read the acronym. It's basically, but our task within Saracen is to do with personalization and recommendations and a social overlay for a peer-to-peer distribution network. Things that we've been involved in, like I say, we're trying to build deliverables that we can then give back to the community. Kendra Initiative is a non-profit organization just producing open source reference modules, really, reference models and modules. You can read what we've got there: Kendra signpost metadata, smart filters, which is portable personalization and filters, preferences. We're looking at standards work, open social extensions, and we've been yesterday and sort of like bits and bobs today, we've been looking at something, a social API, looking at somehow abstracting social networking functionality within Drupal, seeing if we can make it easier for module developers and users alike to actually interact with social networks. And what Klokie essentially is going to be speaking about is Kendra Match, which is searching and recommendations, and I shall just leave it up to him.
So all of these components are available as in various formats on GitHub at the moment. Several are install profiles. Kendra Signpost is an install profile in several feature and contributed modules for Drupal 6, and we're working on upgrading that to Drupal 7 and then 8. But these are all the two first components were part of the Peer-to-Peer Next project, but all of them are being used within Saracen. Just going to flip back. So Saracen is actually a really exciting 3-year project using a number of different partners across the EU, and it basically involves a platform for delivering, presenting, and discovering peer-to-peer streaming video. So we're starting trials in several weeks. If anyone is interested, you should definitely contact us afterwards. We can sign you up for the beta trials. There is a client-side front-end deliverable, which is based on the Qt. It's a compiled software component. At the moment for Linux and Windows, I think there's a Mac component on the way, hopefully later this year. But what we're doing is basically taking in, as users register for the service, using a simple one-click standard Facebook Connect or OAuth token authentication. Users can register with the Saracen service by associating their external social networking profiles with Saracen. And what we do after the registration part is we go out to those external networks, fetch the user's profile data, their Facebook likes, the videos that they said they liked, things they've rated on YouTube, their profile from Twitter, and data mining all the links and the images, etc., from Twitter and from YouTube. And once we have all that data, we're normalizing it and using different strategies within basically coming from the semantic web to normalize them and put it all into a tuple store, semantic web store, which you can do yourself with Drupal 7, or we're using an external Drupal store. which is a bit more scalable. And once we have all the profile data in the normal format, we can do inferencing. We can put it into some other components that I'm going to talk about in order to make recommendations for videos that a user might like, other media that users may like, other users within the system that may be interesting to you as a user. And this is done without revealing any of that private data that's been sucked in from the external networks, but it is leveraged within the system in order to make these recommendations. So most of that falls within Kendra Match, although there are a number of other complementary technologies that we've been working on. So the main components of doing this kind of stuff in Drupal 7, which is the version of Drupal that we're using. There's a Drupal recommender API. It's drupal.org/project/recommender. There are a number of helper modules, which are all linked from that page, which allow you to take the user's activity within your Drupal site, such as browsing around, looking at content, and making recommendations for other nodes that you might be interested in. Also, there's an organic groups helper module, which can recommend organic groups based on your activity and the groups to which you already belong. And there are 3 or 4 other helper modules and several that we're working on. There's a complementary module, which seems to me to be a requirement for using Recommender API, at least within a scalable site, which is called Async Command. I know there are several different projects and strategies within the Drupal community for providing a sort of batch queuing and batch job management within Drupal, and that's really important when we're doing this kind of stuff, because when we're dealing with any sort of large community, we have basically large matrices. We have huge amounts of data, regardless of how much your people are really interacting with the content. We still have lots of users, we have lots of content, and some intersections with the users and the other users and the users and the content. So we have to farm this out to other software or an external service in the cloud, of which there are a couple options, and get it back. And that'll take 1 or 2 seconds, or it could take 10 hours, or it could take weeks, depending on the size of your data and the resources that are available. So it's really important to do this asynchronously, aggregating all the data, putting it into a request, sending that request out, waiting for the responses to be returned, and then doing something with that data once it's back in Drupal. So there's a project called Apache Mahout. I've been calling it Mahout for ages, but it's pronounced like trout, the fish. And it is it's an open source technology that's been taken over by the Apache Foundation for the last 2 years for doing this sort of scalable machine learning, making recommendations, and other things that we'll cover. And there's a complementary but not a required technology called Hadoop, which has become really popular. It's being used by Google and pretty much all of the big companies who are doing this sort of work. It allows you to take multiple instances of Mahout and to marshal them into a sort your own cloud service, if you will, and to make, dump a request into the pool and get something back. And Hadoop takes care of massive complexity of splitting up and partitioning those requests among the 1 or more Mahout instances that you may be running. We're not running Hadoop. We've spent some time trying to get it up and running, and we're somewhat successful, but for what we're doing at the moment, it doesn't seem necessary, and we can talk a little bit more about that later. It's almost easier to come up with popular social networks and third-party services that provide recommendations than those that don't. There are very few that are not providing recommendations and doing these sort of personalization features for the users. Amazon being one of the first and definitely one of the biggest ones. If you like this item, you would also like these products. People who bought these products also bought these products, and aggregating users' activity within the site and using that to make recommendations. Netflix in the US, I'm not sure if they've expanded to the UK or England yet, but it's a video provision service, and they're making lots of recommendations They're well known for offering up a bounty of $1 million US 3 years ago, I think. It was called the Netflix Prize, which challenged anyone to come up with an algorithm or a system that would make recommendations that were quantifiably better than the recommendations that they had been making. That award was taken by someone using some of the algorithms that are, by a group of people using the algorithms that are available within Apache Mahout. Spotify and Pandora are making music recommendations, and that's become popular because it's tied in with Facebook recently. Facebook, of course, are making recommendations for other users, and they're taking on all kinds of different signals to make those recommendations. Not only the people you already know or the people that they know, but your IP address and where you're located and all these things to make relevant user recommendations. LinkedIn is doing the same thing. OkCupid is a dating service in the US at least, and they're making recommendations and trying to protect users' privacy at the same time. iTunes has the Genius for a year or two, which is available within the iTunes product. I don't think they really offer much in the way of recommendations within the iTunes store. I don't know if that's because they have just a huge selection. What is it? 1 billion apps available, half a billion. But I know that there's some work in the ways of tying that in with Facebook so that Facebook could possibly leverage their user community to provide those recommendations for apps and music and movies and all that. So what is this all about? What does Mahout do that Drupal doesn't? There are basically 3 kinds of machine learning that are relevant. The first is called collaborative filtering. We also talk about this in terms of recommender engines, creating a recommender engine to make these sorts of predictions and associate similar content and users together. And then there are 2 other categories, which we won't go into so much, called clustering and classification. Clustering is basically finding nodes of finding entities. You know, it could be products, could be users, could be locations based on certain properties of those entities, and clustering them together. And classification, which basically says, does this item look more like an apple or like an orange? Trying to compare items of a given type and see if they fall within a given set of categories. So far, we've really been only experimenting with collaborative filtering, but that's the main goal of the Recommender API within Drupal, and it's definitely relevant to the kind of recommendations that we're looking into. So I'll talk briefly about what collaborative filtering is. Basically means taking in all of the preference data of your users, which is, it's up to you what that means, but it's up to the Recommender API helper module, if you will, to identify what's interesting in terms of preference data. It could be nodes that users have rated using any of the voting API modules, nodes that people have tagged using freeform or a specified tag set, Folksonomy. It could be simply the browsing history recommender helper module, which is basically that these users have browsed these nodes, and therefore we can make assumptions about what other people may like to browse. That's all different types of preference data. And then what we want to do is put that into this black box, and we get back out predictions of which nodes and content, what content and users, other users with similar browsing habits or activity would be interested in. So just briefly, a preference is it's a tuple which contains the user, which is a UID in Drupal, and either a second user ID or a node ID. And then we associate with that couplet a sort of weight, which is really up to the helper module to determine. Could be a weight of either 0 or 1, just a Boolean saying this user has browsed this node, and then if the user hadn't browsed a node, we wouldn't have a record of it. Or it could be a rating, 1 to 5 stars, could be a tag, and then you have your own system of evaluating where within your scale 0 to 1 that weighting would be derived. But it's assigned integer, so you could have negative weights as well as positive weights. And the prediction that we're getting back from this system is basically going to be, for each of those UIDs, each of the users, we're going to have a second parameter, which would be another node ID or a UID, which didn't exist in that original data set. So if I've been browsing 5 nodes, I don't really want to see those 5 nodes in the set of recommendations that I get back from the system. I don't want to see my friends in the list of, oh, you may like these other users, because I already know them. And then we get a weight back from the recommender system, which is a number from 0 to 1, which is representing the strength of that Mahout thinks how relevant this recommendation would be to me. So, as I mentioned, Mahout is it's a scalable machine learning library. It's designed from the beginning to support really massive data sets, and it's really only constrained by the CPU and the processing power and vast amounts of RAM that you have available to the system. It was launched in the spring of 2010, so it's a pretty young project, but it's been taken on by Google and Amazon and a lot of large as well as smaller players in social networking especially. And it originally grew out of the Apache Lucene project with, has anyone used Apache Solar or Mahout before? Yeah, Solar. Has anyone installed and used Mahout yet? Recommender API, no? Cool. So hopefully this will get more people interested. So Solar is a search component. It's Java software that can run either on the same machine, the same host as your Drupal server, or you can run it from an external server. And you basically just set it up, configure it within Drupal. You give the host name or IP address and the path to Solar, and then Drupal now knows to use Apache Solar rather than the built-in search API for making search requests, and then you can do other cool things with that. Mahout is somewhat similar. You can run it on the same machine. You can run it on an external host. I would definitely recommend running it on an external host because of the requirements in terms of CPU, and also because it's not something that's going to be running all the time. You just want to make calls out to it every minute, every 2 minutes, once a day. It's up to you. And then you want to get your results back, but you don't want it to slow down your Drupal site. We can talk more about that. And so a year or two ago, Mahout, which grew out of Apache Lucene, it was merged with another project called Taste. If you look through the Java source code, because Mahout is also Java, like Apache Solar and many of the Apache Foundation projects, you'll see lots of references to the Taste project. So what are some good use cases? If you want to mine users' activity on your Drupal site and come up with other items and other users that they might like, this is definitely for you. If you want to take some of the documents, document could be a page, it could be any node within Drupal, and you want to classify them, group them by topic, then you'd be interested in the clustering approach. And if you want to take previously categorized documents and see if they fall within given categories, then you'd definitely be interested in the classification algorithms that are available in Mahout. And there's another category called frequent item site mining, which basically means taking a set of items in groups, which could be your shopping cart center if you're working with commerce, terms that a user has searched for previously. And then you want to identify, you want to aggregate those things together and say, okay, if a user searched for these things, then they might also be looking for these other search terms. If a user's been browsing these products, then they might also be browsing these other items within the similar item set. There are a lot of algorithms that are available within Mahout. I don't even know if this is up to date because there are new ones being added. But we can make user recommenders, recommending users that you may know, users whose preferences are similar to yours. We can recommend items which are similar to the items that you've been browsing, or products in your shopping cart, etc. There's the Slope 1 algorithm, which is relevant to the Netflix prize that was awarded. It's a very highly scalable algorithm for making recommendations. And then there are a number of other algorithms which I won't go into detail, but there's lots of information about these, lots of documentation on the Mahout site. And then there's also a possibility for taking the outputs of feeding the inputs into a number of these different algorithms in parallel, and taking the outputs and feeding them into what's called a naive Bayes classifier, and allowing the classifier to take all those outputs and weight them according to what the classifier thinks are appropriate. And so this is working similar to a Bayesian spam filter, which you're probably using all the time, which is able to adapt in real time to new inputs that it hasn't seen before, and vary those weights. So you don't necessarily need to have some hard-coded weights in your helper application. So this is something that we're definitely interested in exploring over the next few months. Hadoop, the Hadoop project allows us to cluster multiple instances of Mahout. It's definitely not trivial to set up, as I mentioned. It can be set up even on a laptop, and it's been done, but I'm not sure why. And it has not been implemented in the Recommender API module yet. The developer of that, the maintainer of that module, determined that it shouldn't be necessary at this point, based on the recommendations that are being made in the helper modules that are made at this point. It's worth mentioning that the Recommender API is a mix of PHP and Java, and it has its own schema, its own tables that it defines within the Drupal world. Originally, I guess at the start of the Recommender API project a couple of years ago, the developer and the current maintainer had built everything in PHP. As you may or may not know, PHP really isn't perfect for these sorts of scalable, massive matrix computations. So he rewrote everything in Java and designed it to work on, ideally on a separate virtual machine, separate host that could be dedicated to running these offline processes. It could be run on the same machine as the Drupal server. If you have access to another virtual machine, you'll probably get better results. But there is a cloud service that's currently in beta, again, offered by the maintainer of the Recommender API module. So if you're interested in that, you can contact him, and he's giving out beta access. Also, Amazon offers the Elastic MapReduce service, I think it's called, which allows you to rent time on the Amazon cloud. If anyone's previously set up Amazon instances, it's pretty easy to get up and running as long as you just put in your credit card details and exactly what you want to set up, and within much less than an hour you'll be up and running with a new virtual machine. You can basically do the same thing with Elastic MapReduce, except you shut it down. It's instantiated when you need to make the call, and you can shut it down immediately after, thereby saving you money and reducing all the costs associated with running this full time. The way that the Recommender API works is we have these Java libraries which basically talk to the Mahout Java libraries. They're loosely coupled, and then we get the response back from Mahout as an offline process, and the results the input to this process is coming through a JDBC. That's the Java database connectivity. It basically talks directly, gets the data directly from your Drupal database, from the Recommender tables that it's set up according to its schema. And then the Java module is instantiated via cron script. There's a batch file if you want to run it on Windows via Sigwin. And then Mahout does its thing. It takes your input, does its computations according to the algorithms it's selected, and then puts everything back into your Drupal database using JDBC and the Java Persistence API into the recommender tables. So I mentioned briefly there are these helper modules already available for Drupal 7 and I think for 6. Browsing history, OG similar groups. I mentioned Uber Cart's product recommender. There's the 5-star recommender, which users who have rated these items highly have also rated these items highly, and therefore we can recommend them to you because you had the first items in your rated kit that you've been saving inside this recommender module. It's also there's also a module available for using the voting API, which is a similar process, and flagging nodes. Users who flag these nodes also flag these other nodes, and therefore we can associate those nodes and recommend them to you. All this relies, as far as I've seen, on the Async Command module, which is linked directly from the recommender API page on Drupal.org. And what it does is it's called, it allows you to queue jobs in a simple Drupal table, and it's called periodically according to your cron setup, and it'll look through the job queue and farm the calls out to the Java library, which then talks to Mahout, which does its thing and puts the results back in your Drupal database. So within Saracen, we're running this batch process every 2 minutes. We're updating users. We're basically making a word cloud of the tags associated with the user based on his everything that we pulled in from Facebook and these other social networks, and we can recompute that every 2 minutes. We're also recomputing the browsing history, and we'll be recomputing all the content ratings and the tags and recommending other content and other users every 2 minutes. We're hosting this all ourselves within the Kendra Cloud, which is in the UK. It's not so difficult to set up yourself if you have root access, for instance, to an Ubuntu system. The documentation is pretty good. You could do it all yourself on a single server along with Drupal, MySQL, whatever else you want to run. Again, I wouldn't advise doing that if you're planning to expand. There's this recommender API cloud service, which I think there's a link at the end of the presentation, and Amazon's Elastic MapReduce, which is another hosting solution I talked about. So if you want to install Mahout yourself, get a dedicated virtual machine. It's available for Linux, macOS 10.5.6 or later, and Windows if you're running Cygwin. You need the Java JDK 1.6 or later. And you need to use Maven, which I wasn't familiar with. I'd set up Solar and a few other Java projects, but have mixed opinions on Java in general. But with Maven, it was possible to get this up and running within an hour or two. So yeah, maven.apache.org. You basically just follow the instructions at this link if you're using Ubuntu. Otherwise, you can, if you're having problems, you can post them to there are 3 different issue queues linked to, I think, at the end. And use Maven to build the examples. There's an example that's included with the recommender API. All you have to do is download a data set, which is called GroupLens. GroupLens consists of, I think, 3 different data sets. Was it 10 million or 100 million ratings by various users, 100,000 ratings, and I think the third one was 10,000 ratings. So this is really nice to have this data available for testing, so you can set up your Mahout server, you can set up Maven, and you can make sure at least it's able to take input and give you some output in an expected format. You're going to need computing power to make this work. If you you have 100,000 ratings, I think the statistics, according to the maintainer of the recommender API module, is don't bother. If you have 100,000 ratings, you have 2 gigahertz, not exactly cutting edge servers, but it's going to take you about 11 days to run that process. I think for the ratings that we've been doing so far, they're all returning in about 10 to 20 seconds, although we have a pretty small data set. But the virtual machine is constrained to, is it 2 gigabytes or gigahertz, or memory is pretty constrained on it. So yeah, install the recommender API to get up and running. Then you want to visit the async command. Set up, there's a special configuration file there called config.properties. There are instructions in that link at the top. Basically, that has to replicate or be consistent with your settings.php file. It's an interesting approach, but basically, this file is required so that the Java library will be able to talk to your Drupal database and get access to at least those recommender tables. So if you're concerned about security, then you probably want to lock it down so you have a specific MySQL user or a database access user who only has access to those recommended tables. Maybe he only needs read access, that would be fine. Set up a separate account for the JDBC layer so they can't mess with the rest of your Drupal site unless you want them to. Then you want to, download and enable async command. And then you want to go to, here's the async command homepage. Tells you briefly about it. I don't know if you can see this. So this gives you a nice little table which shows you the job queue, all the jobs that you've set up for the async command module to parse. There's a nice little test where you say just ping the server, just like the Apache Solar module. Ping it, make sure it responds in the way that I want it to. Success equals pong, and it should respond pretty quickly. There are also 2 nice little tests that are included with async command and recommender API, which allow you to easily, once you've set up Mahout, test the group lens data. Make sure that you not only have access to your Mahout instance, but you're able to shove in all of the group lens data that you want to use and get back some response in the format that you're expecting. Again, I showed you some of the statistics for running the entire group lens job. It's going to take some time. So there's a nice approach within Mahout, and it's supported by Recommender API, to just do incremental updates, basically taking the new activity from your Drupal site, putting that in and getting back the incremental responses from Mahout, merging that back into your recommender tables and presenting that to users on the front end. Not sure exactly why, but here's this job queue table from async command. Sorry, here's the one from the recommender API. Here's the one that's also provided by async command. Basically the same thing. And then there's also a view of the exact same information if you want to turn on the view that's provided with the async command module. And then you also get 2 nice little blocks once you've set this up. You can enable them, and one would be, this is with the browsing history module, by the way, the helper module. So I've downloaded and enabled this for my Drupal site, and I now have these 2 little blocks. One is for presenting personal recommendations just for me, and which I think is only for registered users. I don't think this is working for anonymous users at this point in time, but I'd love to be proven wrong. Browsing history recommendation also provides similar nodes, of course. Based on these nodes, you may also want to browse these other nodes, which I don't think you've seen before. So those are the blocks that. All right. These are the blocks that you get with the browsing history recommender. And you also get some nice views. You get views integration, I should say. All of the information from the recommender helper tables is going to be available via your views. So it's pretty easy to to present this stuff to users in the way that you think is appropriate for your website. So our particular use case is for this Saracen project. As I mentioned, we're taking in all this user profile data from Facebook and other social networks. We're aggregating it. We're normalizing it into a standard format that we can inference upon and make useful recommendations. But at the moment, we have a really limited data set. We have a small number of users for the trial. We have a small amount of content. And to really leverage these technologies, you want to, I would say, probably have at least 500 or 1,000 users. You want to have maybe 5,000 or 10,000 content nodes. And then you're really going to start getting some interesting content recommendations and user recommendations within your site. But the API does provide an initial set of recommended videos. So we also have services integration. So all this stuff is available from the front end to the client app, which is built in Qt, and using the services integration, we can pull out this stuff directly from the recommended tables, or you can use views to present the data on the front end. User can then watch one of these recommended videos. They select it, and we record that click. And then using that, we can feed that back into the recommender input tables via the helper module, which within 2 minutes will get reprocessed by the cron job, and therefore the Java applet, and the Java app, and therefore the Mahout job, which feeds everything back into Drupal. Therefore giving the user some feedback and saying, we know that you've seen this video, and then we can prioritize that. And maybe you also, in developing your own helper module, maybe you also want to use a timestamp and say, okay, this is the more recent activity that we're recording for our users. We're going to prioritize the most recent stuff over the oldest stuff because we think that's more relevant. And so we're generating user and content and user predictions based on similar nodes and similar user activity. And the goal for this prototype is to take all the profile data, feed it into the recommender, and then using multiple algorithms running in parallel, some of which may or may not finish in time for the next cron run. We want to feed the outputs back into this Bayesian classifier and use that to refine the results and present that to the user. So we have explicit data within Saracen, which is all the stuff that people have liked. You could say the tags and ratings within your Drupal site, or stuff if, for example, we're pulling it in from Facebook, their location, anything that you want to track, linked accounts, connections, any other metadata. And then we have the implicit data that we're also tracking, which is browsing history. We have the searches that we're recording. We have when a user shares content with other users, we're recording that. When the user views the new content, we're keeping a record of that in the input tables for Recommender API. If a user creates an album, which is a content collection, we make a record of that. And when they're rating or tagging content, that's relevant. So what I've seen so far is you don't need to, you can do all the stuff basically using Drupal 6 or 7, Recommender API, one or more helper modules, Async Command module, Apache Mahout, and then the Java interface running over JDBC without Hadoop. If your number of users is much, much larger than the number of items or the amount of content. And you can also specify that you only want to make recommendations for certain content types. If your users are browsing anonymously most of the time. If people are not logging in and they don't need personalized recommendations specific to them, or if you're not churning through lots of new content on a regular basis. Of course, equally important, I think, when designing a recommender system, or some of the side effects, is it's not always going to be apparent to the user exactly why they're being recommended certain content and other users. I think that's really important in terms of usability and UX concerns, privacy, of course. decreased serendipity. Basically, we're making these recommendations based on specific algorithms in the helper module, according to the priorities that we have, and that's not always going to be consistent with the user's priorities. And if you're setting up Hadoop, then be prepared to lose a lot of sleep, and in maintaining it and getting it working. So these are the recommender project and the recommender API cloud service links. Here's the link to Mahout is the third one. That's really useful. The documentation is pretty good, especially if you can read through some Java source code. They have good class documentation for most of the item and the user-based recommenders. There's a great book from Manning Publishers called Mahout in Action. Highly recommended if you want to get up and running quickly with Mahout and figure out what's going on behind the scenes, and especially if you don't have much experience with machine learning, AI. There's a good paper on, I guess the link isn't here, but we can give you the link later if you want to read more about the naive Bayes classifier that we have decided to implement in the prototype. And Elastic MapReduce service from Amazon could be a good solution depending on your hosting requirements and availability. Here's a link to the Saracen project. Definitely talk to me after the talk if you're interested, and we can hook you up with the beta test, which should be happening in a few weeks. Did you want to talk more about the project or kind of goals? Okay, so thanks. Can open it up to questions. I'm not sure if I can answer them, but I'll give it a shot. Yes? Do we have a microphone, or? Okay. Okay, so I think the question is about the input for or the way that you're building your helper module. The input that we want to put into Mahout, can it include additional metadata from linked nodes? So that's really up to the helper module. At the moment, I don't think browsing history will include any. It won't dereference any of your entity references, but that wouldn't be so hard to implement in your own helper module. So you pull in that data, and then make your associations within the helper module, and then push it out to Mahout. Yes? Okay. The question, radioactivity is, I should note the first point, a module that I wasn't familiar with, but would be worth investigation. And the second question, what's best to say, to make predictions of content that would be relevant to a single user, or to say that these nodes are similar and therefore you may also be interested in browsing these other nodes. That's up to the site designer. Both those approaches are available from browsing history, but and you can select again which content types you want to restrict your recommendations to. But yeah, that would be interesting in terms of user testing. What do you think is really relevant for your use case? For if you're providing video recommendations, then you definitely want to say these movies are similar to the ones that you've already watched in the past. But it's a bit more subtle and more nuanced to say users who've watched this video have also watched these other videos. So that could be interesting. I might want to do some post-processing once I get the recommendations back from Mahout and say, these nodes also have these other similar attributes with the users, the ratings that you've made or the content that you've tagged. Again, you could do those two tasks as parallel processes and possibly use the classifier to combine them, but that's a bit more advanced. Yeah, preferences change over time. User activity is cumulative. You don't really want to purge any of this activity. You want to, privacy policies and all that aside, you want to tell your users what you're doing, but it's more interesting in the long run to accumulate all this data about the users if you want to make appropriate recommendations. Yeah, basically every time you run cron, you can use your entire data set and just send everything out to Mahout and get fresh results back. Or you can do incremental updates, like is already supported with the example for the group lens data set, 100,000 records. Maybe you want to just do incremental updates, but maybe you've optimized it and you can afford to do an entire dump out to Mahout every 2 minutes or every 2 hours, however often, and you can get entirely fresh results back from Mahout, which take into consideration all the new activity. Definitely, yeah. The two choices that spring immediately to mind is one is filtering out the input data, filtering out some of your old stuff. If you don't think it falls, I mean, you can always incorporate the results that you got back previously from Mahout and say, okay, maybe we should purge some of this old buying data because it doesn't coincide with any of their new behavior. And then the other approach is to select which algorithms you want to use within the Mahout world. Some of them are definitely more appropriate for if you are applying a timestamp and using that to weight, to affect the weight that you're using as input for Mahout. Sure. Yeah, I mean, if you could just normalize your timestamp with I think in Drupal it's just an integer. You could normalize that from 0 to 1, and or use it as a sliding scale all the way up to huge integers, and just use that as your weight. If you don't have any other weight, just feed that directly in as your weight as the input data from Mahout, and it'll use that depending on what algorithm you've used. Okay. What? Any other question? All right. Yeah. I haven't quite made the transition to .org.
So it's change.org.uk for the website and yeah.
Yes. Make a note. Yeah. Okay. Is that time? Okay, thanks.